Okay, in this video, I'm going to run you through how to find each of the different atomic number, mass number, number of protons, number of neutrons, electrons, and whether it's an isotope, ion, or neutral atom. I'm going to go over the answers to this sheet. So our first element is aluminum. So we want to know the atomic number. So if we find aluminum on our periodic table, it's right here. Our atomic number is that big number right on top. That's that 13, okay? So when we go back to our sheet, our atomic number is 13. Our mass number is just below. So when we look at our table, our mass number is right there, that 26.982. We need to round that to the nearest whole number. Okay, so when we go over here, it's already rounded for us. Our nearest whole number is 27. Our number of protons is equal to our atomic number. Our number of neutrons is going to equal the mass minus the number of protons. So this one minus this one. So 27 minus 13 is 14. And then our number of electrons is going to equal our number of protons, unless we're told differently by either it being an ion or it's given to us. Okay? So when we look at this, now is it an isotope, an ion, or a neutral atom? So if we want to know if it's an isotope, we look at our mass number. Is that the same as the mass number in our periodic table? So if we come over here, that was 27. Our mass number here, 26.982. If we round that to the nearest whole number, that is the same as our mass number on our table. So it is not an isotope. Okay, then we want to see, is it an ion? If it's an ion, we look to see if our electrons and our protons are equal. They are equal, so it's not an ion. So this is a neutral atom. Okay, bromine. So here's bromine. Step one, what's the symbol? We got to find that on our periodic table. Okay, here's bromine right here. Okay, our symbol is Br. What do you need? Okay, so when we look at our periodic table, here's our bromine. Our chemical symbol is Br. So we write that in our table. Okay, the next thing is the atomic number. It gives that to us. The mass number, it gives that to us. But let's look at our periodic table anyway. Our atomic number is this number up top. Our mass number is this number on the bottom. So this one we round to the nearest whole number. A normal bromine atom has an 80 atomic mass units mass number. Okay, so that's exactly what they wrote here. So our number of protons is going to equal our atomic number. Okay, it's given us our number of neutrons. Okay, and then the number of electrons. They gave it to us. Now, is it an isotope? No, because remember that mass number was the same as our periodic table. So this is the normal atom. Is it an ion? Well, if we look at the number of electrons and the number of protons, they're different. Okay, there's one more electron. So that is a -1 ion. Okay, so it's an ion. Uranium. So that's our next one. The atomic number, 92. What's the mass number? So we find uranium on our periodic table. Here's 92. 92. So here's uranium on our periodic table. Okay, we need to know the mass number. So we look at the bottom, 238.03. We're going to round to the nearest whole number. That would be 238. So our mass number is 238. The number of protons equals our atomic number, so that's 92. It gives us the number of neutrons and the number of electrons. Okay, so isotope. Did this number and this number equal that number? So if we add these together, they do equal. So it's not an isotope. Is it an ion? So our number of protons and electrons are the same, so it's not an ion. So this is a neutral atom. Okay, the next one is helium. It has an atomic number of 2, a mass number of 4. Remember, the number of protons is the number, the same number as that atomic number. Okay, so there's 2. The number of neutrons. So remember, neutrons are the mass minus the protons. So mass minus protons, 4 minus 2 is 2. And the number of electrons is going to equal the number of protons unless they tell us it's an ion or they give us a different electron number, okay? So when we look at this, is it an isotope? The easiest way to find that out is look at our mass number. Our mass number is 4. If that is the same on the periodic table, that's a 4 as well. That means it is not an isotope. Is it an ion? So let's check our protons and our electrons. They're the same, so it's not an ion. So this is a neutral atom. Okay, helium. Okay, this helium has an atomic number of 2 and a mass number of 5. Notice that's different than our previous mass number. If I look at that 5 from my table and I look at the mass number on my periodic table, they're different. That's a clue that I have an isotope. Okay, so if I go here, number of protons equals your atomic number. So number of protons is 2. Number of neutrons, you take your mass minus your protons. So 5 minus 2, we have 3 neutrons and 2 electrons. So is it an isotope? Yeah, remember this was different, so it's an isotope. The electrons and the protons are the same, so it's not an ion. Okay, lithium, we gotta find that symbol. Lithium is over here, okay? This is lithium, the symbol is Li. So we're gonna write Li in our chart. Okay, the atomic number is 3. The atomic mass is 7. Let's check that atomic mass and see if it's the same. So our atomic mass here is 6.9. If we round that to the nearest whole number, that's a 7. That's the same as in our chart, so this is probably not an isotope, okay? The number of protons is the same as our atomic number, so that is a 3. The number of neutrons is our mass minus our number of protons, so 7 minus 3 is 4. And our number of electrons is 2. So we looked at our mass, we found it was not an isotope. Is it an ion? So let's compare. Our number of protons is 3. Our number of electrons is 2. Those are different. We've lost an electron. So this is an ion with a +1 charge. Okay.